We always picture planets as, well, round, spheres. It's kind of beaten into us in science class, right? Gravity just crushes everything down into a ball. But what if that wasn't the only way? We're about to dive into the absolutely wild physics of a planet that, by all rights, shouldn't exist. A world shaped like a giant donut. Okay, so let's get right to it. Is this for real? Could a planet actually be shaped like a donut? I mean, think about it. Every planet we've ever seen, every star, they're all spheres. A donut seems to just completely break the rules of physics, doesn't it? And yeah, you'd be right to be skeptical. The reason everything's a sphere is something called hydrostatic equilibrium. Basically, a planet's own gravity is so massive it just pulls all its own stuff inward, equally, toward the center. It doesn't care if you start with a big, lumpy potato of a rock, eventually gravity's going to win and smooth it out into a ball. It's just the most efficient, stable shape. Nature loves spheres for a good reason. But, and this is a huge but, there's a loophole in the physics. If you spin something really, really fast, another force comes into play, centrifugal force. You know, that feeling that's pushing you outwards when you're on a spinning ride at the fair? That force can actually fight back against gravity's inward pull. So to get a donut, you'd need this unbelievable razor-thin balance, gravity trying to crush it into a sphere and this insane spin trying to fling it apart. It's not impossible, just wildly, fantastically unlikely. Okay, let's play along. Let's say this incredible balancing act works out and this planet actually forms. So what's it like to stand on it? We're going to start with the view, because what you'd see in the sky is something completely alien, unlike anything you could ever imagine. So picture this. You're standing on the surface, right on the inside of the ring. You look up, and there are no stars. There's no deep black space. Instead, you see the other side of the planet. It's just there, a gigantic arch of land and sea and clouds stretching all the way across the sky, from one horizon to the other. It never moves. It's just always there, a permanent continent hanging right over your head. Now, having that giant arch in the sky does some really weird things to the light. Think about a sunset here on Earth, right? Light passes through our atmosphere once, and it gets all red and orange. Pretty. But on this donut world, the light from the setting sun has to pass through the atmosphere on the farthest side of the arch first, so it gets pre-reddened. Then that already red light crosses the big empty hole and hits your atmosphere, where it gets filtered a second time. The result? You get these insanely crimson sunsets, just unbelievably vivid. Oh, and because the planet spins so fast, the whole show is over in like 15 seconds. Blink and you miss it. And night? Forget about true darkness. That massive arch in the sky, it's basically a giant mirror. It reflects sunlight from the day side back down onto the night side. So even at what should be midnight, the sky on that inner ring would be, get this, 16,000 times brighter than a full moon here on Earth. It wouldn't be night. It would just be this constant, beautiful, shimmering twilight. But all that beauty comes at a price. A really weird one, because the exact same shape that gives you that incredible view completely breaks the rules of gravity as we know them. Seriously, what you would feel on this planet is even stranger than what you would see. So here on Earth, gravity is pretty simple, right? A neat little rule in physics called the shell theorem means that gravity acts like the whole planet's mass is just one tiny point right at the very center. That's why down is always just straight down. Easy. But on a donut, there's nothing in the center. All the mass is in the ring around you. So gravity doesn't pull you toward the middle. It pulls you toward whichever chunk of the ring is closest to you. And that changes everything. And this is where it gets really weird. Let's say you're standing on the poles, so the top or bottom of the donut. That's where you'd feel the heaviest, about 2/3 of Earth gravity. Not bad. But then you start walking toward the outer edge, the outer equator. All that spinning starts to counteract gravity, and suddenly you feel way lighter, less than half your polar weight. And then there's the hole. If you could just float right into the very dead center of that hole, you'd be totally weightless. Gravity would be pulling on you equally from every direction in the ring, canceling itself out. Wild. Yeah, to put some numbers on it, if you weighed, say, 65 kilos at the poles, you'd feel like you only weighed 30 kilos at the equator. I mean, you could lose more than half your body weight just by going on vacation. No dieting required. So you've got this crazy gravity and this super fast spin, and it doesn't just mess with your bathroom scale. Oh no, it cooks up some of the most extreme, most violent weather you could possibly imagine. First off, a day on this planet is only 3 hours long. It's spinning that fast. And that insane rotation supercharges something called the Coriolis effect. That's the force that spins up hurricanes on Earth. Well, here, it's so powerful, it would basically grab any weather and stretch it sideways. You'd get a planet that looks just like Jupiter, with these permanent bands of violent, planet-circling storms. You wouldn't have a storm is coming, you just live in a permanent storm belt. And remember those low-gravity areas near the equators? Well, there, everything gets blown up to epic proportions. The atmosphere is 3 times taller than ours, so you could get storm clouds that tower 30 kilometers into the sky. 30 kilometers! And the oceans? Forget about it. You could get waves 3 times higher than the biggest tsunami we've ever seen on Earth. Just monstrous. But the seasons might be the weirdest part of all, especially if you live on that inner ring. So when the planet's tilted towards the sun, you get a nice warm summer. Makes sense. But then, during the equinoxes, something wild happens. The planet casts a shadow on itself. The giant arch blocks the sun, and the inner ring is plunged into an instant, deep freeze winter. So you'd get a summer, then a flash-frozen winter, then another summer, then another flash-frozen winter, 2 of each every single year. Okay, so let's recap. We've got impossible views, gravity that makes no sense, and weather that wants to kill you. But it all circles back, literally, to that giant hole in the middle. Which brings us to the question everyone's thinking. Could you just jump through it? You know what I'm talking about. It's the ultimate sci-fi move, right? Just walk up to the edge, take a little leap of faith, and gently float across the giant void to the other side. Seems like a pretty cool commute. Yeah, no, not gonna happen. Physics has a way of ruining the fun. Remember how gravity works here? It pulls you to whatever's closest. And when you're standing on the edge of that inner ring, the biggest, closest chunk of mass is the ground right under your feet. So if you jump up toward the hole, gravity just pulls you right back down. Splat. But there is one way you could do it. It's just incredibly dangerous. You'd have to start from a platform way, way up, miles above the planet, but lined up perfectly with the dead center of the hole. Then you'd fall, you'd accelerate down, pass through that zero gravity point in the middle, and then the gravity from the other side would start pulling on you, slowing you down until you stopped at the peak of your arc. The catch? That line through the center is what's called gravitationally unstable. Veer off that perfect line by even an inch, and the ring's gravity will snatch you and just slam you into the wall at incredible speed. One of the papers on this really puts it perfectly. This wouldn't be some gentle float. It would be the deadliest, most difficult extreme sport you can imagine. We're talking a wingsuit dive where you have to constantly make these tiny, split-second corrections just to stay on that invisible, gravitationally unstable line. One wrong move, one little gust of wind you didn't account for, and that's it. Game over. So in the end, what are you left with? You have this planet it's a masterpiece of physics, right? A true marvel. But it's also a deeply, profoundly hostile place. It's got this impossible beauty, but it's all governed by these physical laws that just feel wrong to us. So I'll leave you with this question to chew on. If we ever actually found a planet like this, would we see a paradise of cosmic wonders, or would we just see a beautiful, beautiful nightmare?